Hello friends, welcome to today's episode of Problem of the Day series from Leetcode. Today we are going to solve problem 1456, maximum number of vowels in a substring of a given length. So the problem statement is like we had been given a string s and an integer k. Return the maximum number of vowel letters in any substring of s with length k. So that means that if I have a string s, any substring of length k, count the number of vowels in this. Then you can have another substring of length k, count the number of vowels in this, and keep on doing this, right? And at the end you have to return the maximum number of vowels that you have seen. So as you can see that one way of solving this problem is simple naive approach, as you get all the substring of length k and in each substring you calculate the number of vowels. This is a string, right? So you get all the strings of starting from 0 to k, then you go from 1 and then k, then from 2 to k, then from 3 to k plus 3, sorry, k plus 2 and k plus 1, right? So you will be keep on doing it, and then for each substring you will go and check the number of vowels. So effectively it is actually not n square, it is O of n k, where n is the number of characters in the string and k is the length that has been given. Can we do better? So if you take a look at how I was drawing this, is that in this string you start from say string 0 and you have a length of k, right? You calculate the number here. So let's say it's a C1. Okay, now we are going to check the number of vowels from index 1 to k plus 1, right? And it has a C2. If you notice that the number of vowels present in this substrings does not change, they are same, right? The only thing that changes is the end of the character and it is the start of the character. So let's take a look how the sliding window approach will work here. So initially my window start is 0 and window end is 0, right? And this character is actually a vowel, so my current count is actually equal to 1. And since my the width of the window, which is WE minus WS, is less than K, so we will not do anything, we'll just move to the next part. So now my window end moves here. Now window end is saying, okay, now this is not a vowel, so this will not change my answer, and the width is also less than 3, so let's move it to the next one. Again, the C is not in a vowel set, and so C is not in the vowel set, and the width of the window is not more than K, which is 3, will not do anything. Now coming here, now I is in the vowel set, right? So now when you add a vowel set, now my current count is now equal to 2, because first one was seen here and it is I. Now if you notice that the width of the window is actually more than K, which is 3 here, more than 3. So we will shrink this window. So initially your window start is here. So we'll shrink this window, means that now we'll move it here. So to move here, you have to check whether this character is a vowel set and was contributing it to the window. We'll just subtract it. So now since it is a vowel, we will subtract and this will become 1. So that means that from this set, it actually the length is 1. Similarly, now we go into this particular window, increment WE. So this will change the count 1 plus 1, which is now 2, and B is not in a vowel, so it will not change my vowel set. and in the next count it will be I, which is 3, and C is not in a vowel set, so this will not impact the count, so it will be 3. So similarly we will continue move towards as WE is less than your S dot length. Okay, so we are going to first create a easy way to check whether a character is a vowel or not. So for that we can create a simple hash set of characters. You can call it vowel set is equal to new hash set of character, and we can initialize it with A, E, I, O, U. Okay, now as we discussed, we are going to maintain the current vowel count in the sliding window, initialize it with 0, and our result, which is the maximum vowel you have seen, so we'll initialize it. Right now, for a sliding window we are going to have two variables, window start and window end, and we will keep moving this sliding window from left to right. So we will say for integer window start is equal to 0, window end is equal to 0, and we'll keep on doing until we reach window length. Let's make it simple, str dot length and plus plus window e, because we are going to move the sliding window towards right. Okay, now so we have now we are going to add str of we in the window, right? So what is going to happen is, if the vowel set dot contains str of we, that it already contains this, will update the plus plus current vowel count. Okay, now now we have added this window. So since we are building in the starting, we might be just building the window. So if you take a look in this, in the starting, right, so this is your ws, this is we, and then we keep on moving. Say k is here, right? So and this is your we. So as long if my width of the window which is we minus ws is less than k, right, that means that we still have not built the window. So let's continue, we'll not add the we will not work on the start of the window. So in this case we'll update the result is equal to math dot max current vowel count, comma, result, and then continue. And then we'll remove str of ws from the window. How we'll do that? It is same as this. We will check if the character is present or not. If it is present, then we will just subtract it. After subtracting, we will increment the shrink the window basically. So we'll have ws and we will update the result. Then you just return the result from here. Okay, and submit it, and that works fine. Sounds good. That's it for today. See you guys tomorrow. Thank you.